We're good to go.
All right, Tracy, can you see my screen?
I can.
Awesome. All right. As Tracy said, I'm Bethany Seubert. I'm the product manager for the dedicated outdoor air systems group here at Greenheck. Maybe a familiar face. I've been on a couple of webinars. I think previously, October, November, I had done one on IEER rooftop regulation updates. So today, taking a different point of view, now just looking specifically at DOAS 100% outside air regulation updates that we have a lot jam-packed into, a lot of regulation changes coming in the near future. So definitely wanted to give you some education on all of those. So some of the areas that we will be covering today, we will be going over DOE efficiency updates specific to DOAS. So as I said, a few months ago, I had done one on DOE rooftop efficiency regulation updates. Now, very different than DOAS efficiency updates. And really where that comes to play is when you look at IER versus ISMRE. So we're going to deep dive into the differences between those. And actually what DOE is regulating is called ISMRE2. So we're going to look at all three of those, what the difference is between them and what you need to know. And then we'll look at a comparison of ISMRE when you look at different energy recovery options. So ISMRE is that new DOAS regulation for efficiency for that equipment. So when energy recovery is applied to that, how does it change? We'll also look at an IECC update to DOAS equipment that may affect you in the future. In addition to that, there are some UL safety standards that are changing with this equipment, so we'll cover those. And then finally cover a few updates on Greenheck outdoor air equipment. So first things first, jumping into the DOE update. So there has been a lot of communication, a lot of changes and publications around what the DOE is doing to regulate DOAS equipment. And they've put out a lot of publications, I would say, in the last 6 months. So one of the biggest ones is beginning July 24th of this year, so about 6 months away from now, the DOE, Department of Energy, will require efficiency metrics to be provided for manufacturers for direct expansion dedicated outdoor air systems. So really, what does this mean to you? So for you, you will start seeing us as a manufacturer start laying out an ISMRE2 value for our DOAS equipment. Currently, we provide an ISMRE value, which is per 90.1 requirements, IECC requirements, but this is the first time DOE is actually grabbing hold of the efficiency metrics for DOAS. And they're adapting to a little bit different version, so we'll walk through that here today. And then the next piece here is the DOE will ensure compliance for minimum ISMRE values in the following calendar year. So you'll start seeing those ISMRE values from us starting in the mid part of this year, that ISMRE2. And then the following year is when the DOE is going to ensure we're compliant with their minimum values. The biggest thing here is currently the DOE only actually regulates IER for packaged rooftop equipment. So this really puts a line in the sand, gets rid of some of the gray between a DOAS system and a DX packaged rooftop that's recirculating a large majority of the air in that unit. So we'll walk through those differences here today, but I wanted to first and foremost get that out there to show you this is what DOE has announced. This is what's coming in the changes for what the Department of Energy is regulating for DOAS equipment. Now, what is the difference between all of these different efficiencies that are out in code and being regulated? So we'll walk through each of them here. So the first one, IER, probably the one that most everyone here is familiar with. And again, we spent a lot of time talking about in previous webinars. So what is IER and how it's tested? It's important to walk through this, even though this is the one we're most familiar with, so that we have a good comparison between that and ISMRE. So IER is the Integrated Energy Efficiency Ratio. It's really a weighted calculation of efficiencies at different weather bin data points. So it applies to packaged rooftop split systems for air conditioning equipment in the commercial space. And it's expressed in your cooling capacity over the power input to achieve that amount of capacity. So how is this tested? Well, let's look at a unit here. So this is an RV, for example, here. When you're doing testing to calculate an IER value, you're taking in return air in through the return intake of the unit, and it's entering always at an 80 degree dry bulb, 67 degree wet bulb, entering that DX coil. That is representing your mixed air condition at all different weighted points. Now, when you're addressing the ambient air hitting your condensing coil in this test procedure, you're actually testing at 4 different ambient points, right? So now your ambient conditions change here, your mixed air, because there's so much return air, stays pretty close to that 80-67. Here you can see points A, B, and C, and D are at different dry bulb conditions. And then there are actually different weight percentages towards the full IER calculation based on the amount of time per year that you're in these design conditions. So this test procedure is per AHRI 340-360, and it's very indicative of a standard rooftop unit that's handling less than 25% outside air. So again, just to lay the groundwork, there is a significant amount of return air provided with calculating this rooftop efficiency for IER. Now, when we look at ISMRE, what is ISMRE? A mouthful here, integrated seasonal moisture removal efficiency. So similar to IER, it is a weighted efficiency. So you're looking at weather bin data throughout the year. But this one is very specifically designed for dehumidification of 100% outside air. Very different than your standard rooftop unit, right? And in this case, this is actually expressed in pounds of moisture removed, because again, these units are designed to dehumidify the latent load in the outside air over the power input to achieve that. So ISMRE is actually based on AHRI 920, and it's a 2015 version. And that'll matter when we look at ISMRE2. So how is ISMRE tested? So take a very similar unit. It can come with or without energy recovery here. However, now we're going to be pulling 100% outside air through our intake hood, and it is tested at 4 different points. Unlike the IER calc, that's constant entering your DX coil at 80-67 at all different conditions, we are at 4 different weighted points coming in through our outdoor intake that'll hit our wheel and or our DX coil here. In addition, the same conditions are hitting our condensing coil because the ambient condition is obviously the same here. And then you'll see the different weight percentages per the different test conditions. So again, very different test procedure here, very focused on 100% outside air that's dehumidifying the outside air. And this test procedure will have different testing for with energy recovery and without energy recovery. And we'll look at that more here today as well, how that changes your ISMRE rating. Another view of comparing ISMRE to IER is just looking at those points at which you're entering your evaporative coil on a psychometric chart. So this really tells a story too of how different these calculations are, and frankly, why there was a separation between IER and ISMRE, because a standard rooftop unit is not doing the same as a 100% outside air unit that's dehumidifying the full load of the outside air. So here you can see those points A, B, C, and D are all at those different outside air ambient conditions that are entering your evap coil without energy recovery in this case. And then for IER, all of those points A, B, C, and D entering that evap coil stay the same for every single test condition. It's just changing the ambient coming across your condensing coil. So again, return air versus 100% outside air. Now, you're probably thinking, why is there ISMRE and now an ISMRE2? And why is the DOE chosen to go with ISMRE2? So when ISMRE first came out, the DOE looked at what was released from AHRI in 20 based on calculating ISMRE, the testing procedure. And they had a couple of questions, concerns, adjustments, and changes that they would like to see be made. So that's where ISMRE2 comes into play. So instead of just it backfilling ISMRE, they actually renamed it to ISMRE2. So what's changed and why? Well, there's a few key points that have changed between the ISMRE value and the ISMRE2. First one, reheat is no longer required for the testing process because different applications do and don't require it. They've pulled that out of the testing procedure to have it a part of the unit that's being tested. So that's one of the biggest points here. Some applications do and don't require it. Some code may not allow it. So it was pulled out of the testing procedure. The other piece that was added into ISMRE2, you can no longer over dehumidify to take credit for it. So basically what this means is if somebody wanted to dehumidify their unit down to a 50-degree dew point versus a 55, they could actually remove more moisture from the air with maybe little additional power input to do so. You can't take credit for doing that as a manufacturer. Everyone has to dehumidify to the same condition. So that was clarified with ISMRE2. Another piece that was added or adjusted, I should say, external static was increased from an average of a 1/4 inch to 1 inch, depending on airflow, right? So this is just an average increase. It's just to better represent the applications that this type of equipment is being applied in. So that is a change in the test procedure. Another one is there was a change to the weight of all the points. So in the previous slide, I showed the percentage at which each point was used in the calculation. Those weights were adjusted slightly in ISMRE2. And then finally, there were some changes to the outside air conditions for points C and D. So a lot of the changes here were to allow for more reliable testing in the labs and a better representation of actual conditions. So when we look at the differences here, there's quite a lot of changes that went into this, hence going from ISMRE to ISMRE 2.0. So when you look at the test procedure, now we'll pull up ISMRE2. Again here, really the same process as ISMRE, but some changes in the calculations here and a few in how you're testing with not having reheat or minimal reheat in your calculation for the test procedure. So here, this is AHRI 920, 2020 version that is adopted by the DOE. Same process here, 100% outside air entering our weather hood into energy recovery or directly to our DX coil if you don't have energy recovery. And then I just have highlighted here some of the conditions and weights that have changed per the ISMRE to ISMRE2. So again, basically a lot of it stays the same, but some of these calculations, the weights and the test conditions specifically for C and D have changed. Now, if you put them all together, side-by-side comparison here we're showing IER, ISMRE, ISMRE2 to give you a comparison of all of them. Again, it's really these conditions that are entering our condensing coil and evap coil that are different between the two. And notice also that the wet bulb conditions are important for removing moisture, right? So ISMRE, ISMRE2 will be a part of your evap entering air condition. And then also just your units at which these are measured. IER is looking at your total MBH over your power input to achieve that, versus ISMRE is looking at how much moisture are you pulling out of the air with the power input to achieve that, right? So in a few changes between ISMRE and ISMRE2. Now, there is another piece to ISMRE2 that I would say some people may bring up to you, although it's not necessarily listed out in the DOE or some of the code. It may be something that you may want to look at for future reference when you look at a DOAS unit. So there is 2 different test procedures in the AHRI 920 standard, which give you calculations for this ISMRE2, which we've discussed more in depth here. And then there's also what they call ISMRE 270. ISMRE 2, again, is where they've pulled out that reheat or minimal reheat. So an example could be dehumidifying to 50, 55 without reheat, or reheating to 60 degrees. which we'll talk a little bit more about here with some of the IECC updates for DOAS. Or ISMRE2 would include reheating up to 70 degrees, or if you have supplemental heat, depending on an application like gas heat, electric heat, getting you up to a higher temperature after you dehumidify. An example would be a lab, a clean room, or process example, industrial type example, right? So there are definitely differences between these two. However, when you look at what code is providing, they're all going to stay at the ISMRE2 level. So we compare the difference between all of these. I have an example here to show the changes in the ISMRE to ISMRE2, and then also looking at if you were looking at an ISMRE2 70 example. So here we're showing a Greenheck DOAS example, so an RV25 at 15 tons. The previous ISMRE rating, that unit would have been at 9.4 for an ISMRE rating. Now with the adjustments made to the new testing procedure, the different conditions, the different weight percentages per condition, that ISMRE now becomes an ISMRE2 of 8.4. In both cases, the ISMRE minimums, our units are well above those, right? But you will notice that the ISMRE minimum has slightly shifted down for the ISMRE2 here, given those changes in the weights and conditions. And then the thing to note here is for ISMRE 270, here we're showing an 8.3 accounting for reheat as a part of the system. Again, it's not going to be shown in codes or in DOE or in any other standards other than the test standard procedure laying out what that test process looks like. But it's good to understand what that is. If you're trying to understand if a manufacturer is using cycle reheat well, i.e., what is their modulating head pressure sequence, staging of compressors in those at those different points in the test procedure, how are they cycling reheat? Are they doing a good job of it at all those different conditions? That's what that ISMRE 270 could give you. So you could ask a manufacturer to provide that because they should be able to calculate that for you if you're concerned about them using their reheat cycling well. However, it's not going to be a part of your DOE requirement or an IECC or 90.1. So it may be irrelevant, but it is something that is calculated in the AHRI 920 test procedure. All right, so next question probably is ISMRE in ASHRAE 90.1 and IECC, and what versions is ISMRE a part of? So the original ISMRE is in IECC 2021. I believe Georgia's still on 2015, so it might not be something you've seen, probably heard about, but if it's in IECC 2021, depending if you're designing outside of state, maybe it's not something you've utilized. It has been a part, however, of ASHRAE 90.2013 and greater. There have been minimum ISMRE ratings in 90.1, 2013, 2016, 2019, and the latest version of 2022 is actually an addendum to now go to ISMRE2 instead of ISMRE. So that snapshot here is just showing that change in the addendum that's out for public review right now. Obviously, the DOE, providing that they are starting to regulate, you will see all of these codes and standards start to switch over to ISMRE2 so that they all can join into one rating of that ISMRE2. So I did want to point that out. If you have seen ISMRE before, which versions of code and standards those are in, and then what is coming as far as changes in the future. Now, from a standpoint of looking at this in ComCheck, depending if you're selecting at IECC 2021 or 90.1, right? Depending on what you choose for which standard you're following here, you will see if ISMRE is a part of those versions. You will see now a cooling equipment option for DX DOAS units or DX DOAS units with heat recovery. And you can see the example below. That will then populate a dehumidification DX DOAS unit. And it will then, this one was selected with heat recovery, it will then give you a minimum ISMRE rating instead of what you've probably been used to in the past is an IEER, because there really wasn't other options in ComCheck. But you will see that ISMRE is in here, and ISMRE2 should shortly follow once all these go through addendum and adoption, which should be fairly quick, seeing as the fact that the DOE is now starting to regulate with the ISMRE2 value. So of course, the one thing you noticed here is that there's an option for with and without energy recovery in ComCheck. So we're really seeing a separation between your minimum requirement. If you're required to use energy recovery, your minimum efficiency rating is going to increase. So that makes sense, right? Energy recovery technologies or an enthalpy recovery technology is designed to, and typically, especially in your market, to remove moisture. So it should allow that pounds per moisture removed per power input. It should allow that number to greatly increase because now the energy recovery device is removing moisture with little additional power input to do so. So it should allow for a much higher rating, hence the minimum efficiencies are going to be higher for when energy recovery is required than without it. So what does that look like? What does ISMRE look like with energy recovery and without when you do a comparison of a similar airflow? So we have an example here. If we look at a 2000 CFM DOAS unit, at a 95-degree dry bulb, 78-degree wet bulb outside air condition, you have an option with energy recovery and without here. So if we look on the left side, here we're showing our RV25 at 12.5 tons. Again, no energy recovery, 2000 CFM, trying to hit a 55 leaving air temp. That ISMRE is 8.5. That full DX system is responsible for all the moisture removal, right? So that ISMRE rating, that pounds of moisture removed versus the power input to do so, is requiring 12.5 tons. So naturally, you would expect that value to be lower for an ISMRE rating than if you say, let's take that same design condition 2000 CFM DOAS unit at 9578. Now we apply energy recovery to it. Now we actually only need 5 tons of DX capacity because the wheel is taking care of the rest. Here, our ISMRE is 9.3. So what's really great about the ISMRE value is it's pulling it all together. It's pulling that full system together for when you have energy recovery and when you don't. So another great comparison for you as an engineer to look at, well, what's my ISMRE rating with energy recovery or without? Does it make sense? Does it not, depending on my conditions? Because that enthalpy recovery device could be a different technology too. You can compare a wheel to a core or different technologies in the market. So if we do that here, we can actually pull in another example. What's a wheel versus a core look like? So in this example, I'm showing 2 17.5 ton units. Here is a core unit at 17.5 tons and a wheel unit at 17.5. You'll notice here that that energy wheel ISMRE moisture removal efficiency is 9.4 versus with the core is at 8.6 at this 17.5 ton unit. So a couple of things to note here though, the size of the enthalpy recovery device and what type of enthalpy recovery device you're using definitely matters in your ISMRE rating. So for example, let's say this wheel wasn't as large. Maybe you had bypass dampers around it, right? Maybe it was 10 inches smaller in diameter. That could certainly drop the ISMRE to what the enthalpy core is, or even lower. So this is a really great way for you as an engineer to understand, is the unit that I'm being provided, maybe from my rep or that I'm laying out on this job, is it the most effective option that I have to dehumidify the air from an energy efficiency standpoint? And again, it's really great because it pulls it all together with energy recovery and the DX system combined. So why the difference here between wheels and cores? We can do a side-by-side comparison between wheels and cores here, just to give you an idea of of why you see this difference in ISMRE ratings and what some of the advantages might be over one or the other. So when we look at the different technologies here we're just showing our options that we offer for enthalpy recovery device. But you'll notice that there are a couple different types of materials in the market. So for example, for an enthalpy wheel, you may see a polymer or an aluminum style wheel. And then with a core, fiber or polymer as well. So what are the differences here? One, you're going to see airflow ranges differ. So a core is a static, basically a static cube, right? So as you go up in airflow, pressure drop increases. So to stay within the same box housing, you would have to have multiple cores. It won't be able to achieve as much airflow in that case. So that's one thing to note here. Total effectiveness. So the wheel is able to transfer more latent energy than what a core is. So from a total effectiveness standpoint, the wheel is going to have an advantage, hence that ISMRE rating typically being higher. Again, it matters though how big that device is, so keep that in mind. Cross leakage though, that's a big advantage of a core. And it has the ability to have 0 to 1% cross leakage. Depending on your application, that may be something you're looking for. Another advantage here of a core would be less moving parts. It doesn't have a motor or a belt like a wheel does. So some may choose that as a preference here as well. But ultimately, at the end of the day, the wheel is going to have your highest effectiveness total possible here. And we'll do a comparison so you can understand where that difference really lies. And it is definitely in that latent effectiveness, which of course you see in that ISMRE rating. So here's just laying out a few different options that we have to give you an idea of the change in total effectiveness, sensible effectiveness, and understanding the change in wet bulb here. So this example, we're showing selections for a 2000 CFM unit, 91-degree dry bulb, 77-degree wet bulb. Equal airflows for outside air and exhaust here. So in this example, we're showing cabinets that are very similar in size. However, they have different size energy recovery devices. Again, that will play into your ISMRE rating. Here, a 41-inch wheel has a total effectiveness of 74.4% and a sensible effectiveness of 77.2%. When you look at the wet bulb, though, that's where you really see the difference between the wheel and maybe that third line in the polymer core. Now you see that the wheel is able to achieve a lower wet bulb, removing more of that moisture than what that polymer core is able to do. That plays into significantly into that effectiveness value shown here, that total effectiveness of 65.3 versus that 74.4. But notice that the dry bulb temperatures, 78.7, 78.6, are almost identical. So sensibly, they're very similar from that regard. So again, the big difference here between wheels and cores is the latent effectiveness that they're able to provide versus a core, which will help you have a higher ISMRE when you look at similar sizes of those devices. So just to recap, the DOE is imposing efficiencies on this type of equipment, on DOAS equipment specifically, and they're showcasing a minimum ISMRE2 rating for with and without energy recovery. So here's a snapshot of what those minimums are. You can see here that they show the ISMRE2 minimum at 3.8 without energy recovery, and then with is at 5. And again, manufacturers are going to start listing this by July of this year to ensure compliance with the DOE. But to meet these minimums, we have to meet these minimums as manufacturers by May of the following year. So the dates are a little funky about what is going to be mandated when. However, as manufacturers, we have to start showing it in July. So you're going to start seeing that from manufacturers this July, if you haven't seen ISMRE in general from manufacturers already. So I know that's a lot. There's a lot of information to unpack with the DOAS piece specifically, especially with the change between ISMRE to ISMRE2. But with the DOE starting to regulate DOAS equipment for the first time ever, it's a big deal. It's a big change, a big shift for the market. A few other updates I wanted to share with you, which kind of tie into some of the things I talked about here. Another one is there is an update to DOAS sequences in the IECC, which is also a part of ASHRAE 90.1. So I wanted to share that with you today so you had an idea of what that looks like. It is in the 2018 version of IECC. So if you're on the 2015 version, maybe you have or haven't seen it, depending on where you're designing. But basically, this is adding an additional sequence. Again, it's a part of ASHRAE 90.1 2016 as well. But basically what this says is if a unit provides ventilation air to multiple zones and operates in conjunction with zone heating and cooling systems, so basically they're saying a DOAS unit feeding multiple spaces, right? That has an air handler taking care of the additional sensible load. It shall not use heating or heat recovery to warm the supplier to greater than 60 degrees. When that building load or outdoor air temperature indicates that the majority of zones require cooling. So basically what it's saying here is if you have a DOAS unit and you have a call for cooling based on outside air conditions or based on the zone, you can't reheat to greater than 60 degrees. Okay, so that's what this new piece is saying. I guess could be new to you and maybe something that you've seen already before, right? Depending on which version you're on. But one thing I wanted to point out here is there are sequences available allow you to meet this code requirement. So there are sequences for this specific example. We call it outside air reset. Other manufacturers might call it something different if they're utilizing it. But what this basically says is depending on what your outside air temperature is. So let's say if you look at this graphic here, if your outside air temperature is below 55 degrees, saying it's cold outside, right? Then our supplier set point is going to be 70 degrees. Then we're going to call for heating. That's not going to be a big deal, right? Because this code's saying if it's requiring a call for cooling. But now as the outside air temperature increases, right? If the outside air temperature indicates that they may require cooling, well, if outside air temperature increases, the likelihood of call for cooling in this space is going to increase. We're actually with this outside air reset function going to start lowering our supplier set point. And it's going to continue to ramp down as that outside air temperature increases. And then maybe finally at a steady state at 55 once you're above a certain temperature. In here, we're showing if it's above 65 degrees outside, our supplier set point will adjust to 55 degrees. So this could allow you to meet this 60 degrees based on outside air temperatures indicating there's a call for cooling. And all these temperatures are easily adjusted in the controller as well. So this is just an example where it provides you really to have a different discharge temperature in summer versus winter. One other thing to note here is it could change how you're designing your system, right? If 60 degrees is too cold, if you're doing a displacement system, what have you, and putting that air, that 60-degree air into the space is too cold, then you may have to look at ducting to your ventilation unit to your air handler. So it could change the way you're looking at how you're designing systems depending on what type of system you're designing to. So something to note with DOAS, and a part of the reason why some of this reheat language has changed with ISMRE is due to this change in the sequence. So this is really saying if you have a call for cooling based on outside air condition or building load and you're dehumidifying, we don't want you to reheat back up too far where then your air handlers would go into cooling. So it's trying to prevent that situation here, but then does definitely put some obstacles in your way from a control standpoint and a design standpoint. So again, this is a part of 2018 IECC. It's in ASHRAE 90.1 2016. So something to be aware of as well. Now, in addition to that, I wanted to cover a UL safety standard change that is also happening with HVAC equipment. If you haven't heard about this already, we'll just high level provide you some information on it so that you understand how it could affect you. So for this type of equipment, you're usually going to have a UL listing of 1995 for a safety standard. that is actually being replaced with UL 60335. And all equipment must be listed to this new safety standard by January 1st, or that equipment has to lock into a UL 1995 5th edition. So something to note on that, if a manufacturer chooses to lock into the UL 1995 5th edition, no changes can be made to that existing report. That means no unit design changes or part substitution changes. Anything that would be changed for that unit that it could affect testing or safety cannot be made at that point if you lock into the 5th edition of UL 1995. So many manufacturers are going to be switching over to this UL 60335, and that has to be met by the end of this year. What changes are coming from that? High level, there's a lot of pieces to this new safety standard. High level for all of you, there's a lot more stringent testing requirements from a safety standpoint, which is obviously a good thing for everyone. It does reference, or I should say cover, slightly flammable refrigerants from a safety standpoint. There are some electrical safety updates in it, additional labeling requirements in it. Another example, UV lights. If UV lights are provided in this equipment, there's some changes in the safety requirements around those, right? Maybe you've utilized those more in units with COVID, or seen them utilized in design examples because of that, or microbial growth, right, on coils. So there's a few changes that have been imposed from that. From a Greenheck standpoint, we've actually completed 40 plus witness tests with third party through Intertech so far to date to meet this new safety listing by 2024. And the reason I reference that is for everyone on this call, it's likely a change in your spec, right? But from a manufacturer standpoint, there is actually a lot in this safety standard that is a part of the testing process for this new standard. So you may see some manufacturers stay on this UL 1995 5th edition, but again, that kind of locks that unit into its current design and parts that are approved. But switching to this new 60335 obviously allows you to make a design and improvements to your equipment. So what does this mean to you? How does this affect you? Your spec will likely need to be updated, right? Probably in a nutshell, the biggest change you're going to need to do. So this is an example of a spec note you might have. The entire unit shall be ETL certified per UL 1995 and bear an ETL sticker. That likely now just needs to change to UL 1995 5th edition or UL 60335 if you want to make sure you're covering your bases with, depending on what manufacturers are doing, right? You may see some changes to location of components, the type of components to meet the new standard. For example, you may see a VFD change from a certain model to a different model that meets the new safety standards. So though some slight changes like that you may see in components, or maybe something you might not even notice, but manufacturers are definitely going to have to make changes to meet that new safety standard. So overall, you may see some more labels on equipment, some minor component updates, and again, overall, additional safety testing of equipment, which obviously is a good thing, ensuring the safety of this equipment. All right, so hopefully that covers, I know, 45 minutes of jam-packed of a lot of DOAS updates, UL, DOE, IECC. I'm trying to give you a high-level view of some of the changes coming down the road, I would say within the next year and a half for this type of equipment. But to just give you a brief few minutes of what Greenheck's offering from outside air equipment, hopefully you're familiar with this already. If not, maybe it's a refresher. Obviously, from a Greenheck standpoint, we definitely are offering this outside air, dedicated outside air type of equipment for both partial recirc and 100% outside air applications. So we're providing this type of equipment that can be applied to many different ranges here. We do a lot in education, classrooms, gymnasiums. So our units can provide single zone VAV, multi-zone VAV, or a DOAS design system, right? Corridor ventilation, we do a lot of healthcare. DOAS is also being applied to food service and kitchen and dining areas more predominantly now as well. But what model are we offering here? We're offering models RV, RVE, and RVC. Those are just different variations of the same housing with or without energy recovery. RVE is with an enthalpy wheel, RVC is with an enthalpy core, and then our RV model is obviously without either of those technologies. So just to highlight here, we do offer outside AHRI equipment from 3 to 70 tons, all the way up to 18,000 CFM. And one of our most recent additions is adding that total enthalpy core here. But you can see from a heating and cooling standpoint, indirect gas, package DX, probably the primary utilized in this housing. But we do offer air source heat pumps, which is becoming more predominant, particular in the western and northern parts of the US, from 5 to 30 tons as well. A few updates to give you on our equipment, and this would have been covered last time because we've made these updates, I would say, earlier in the previous year. But just something to note, we have made efficiency updates to our equipment. Again, we've increased these more from an IEER perspective, and which also increased our ISMRE. Our units have now standardized on inverter compressors and lead DC condenser fans to meet higher efficiency metrics. We do offer single compressors, single circuit from 5 to 17.5 tons, and then tandem compressor single circuit from 20 to 30 tons. Were some of the biggest updates with our equipment. And then I wanted to spend just a few minutes on microchannel coils, because we have upgraded to microchannel coils for condenser and reheat coils. Although we have been using microchannels for quite a few years, on the 5 to 30 ton, those recently updated in the last year. But we've been using microchannel on, I would say, our smallest housing and some of our largest housing previously to that as well. And where microchannels help you is they improve your efficiency and also have a lot of other benefits like lowering the weight. So just taking a just closer look at microchannel coils here briefly for the moment. When you compare microchannel to a fin-in tube, there's lots of advantages, and that's why you're seeing many manufacturers move to them. Obviously, an improved efficiency is a big one, but there's a lot of other great advantages here as well. It's a compact design. It's actually 50% less weight than a fin-in tube. It requires less refrigerant, and you get better heat transfer. So if you look here at the comparisons on the right hand of the screen, you're going to notice that fin-in tube coils are much larger in diameter here, whereas the microchannel coils, you have many tubes that are on a flat plate design here. They have many that are stacked right next to each other. This design, what it allows here is from an airflow standpoint, if you look at the bottom screen here, from an airflow standpoint, we're actually able to hit much more of the perimeter of the refrigerant tubes with this design. So smaller tubes, the airflow is able to hit much more surface area of those smaller tubes to be able to create more heat transfer there. And then these larger two diameters where the airflow is kind of weaving through here and doesn't hit nearly the perimeter surface area as it does with the microchannel. That allows for that increased efficiency here and the ability to lower the weight, lower the size of the coils, and overall improve this coil designs that's being used in this type of equipment. So another big piece here too, from a corrosion standpoint, they are all aluminum versus a fin-in tube. That aluminum and copper connection can cause corrosion issues. So that's another piece. I wouldn't say that's the high level piece that everyone's looking for, right? The efficiency is the big one, but it's an added bonus to switching over to the microchannel coils. So I wanted to briefly give just a high level view of the difference between the two there. Obviously, we're providing this with some of our coils on our equipment to improve efficiency. There are also a lot of other features we're providing for our equipment. So we'll just briefly walk through those here. So our housings offer a lot of standard features to just improve the longevity of the standard piece of equipment you're getting from us. So standardly, our units are provided with exterior coating that's 2,500 hour salt spray rating. Again, standard, you don't have to ask for it. You will always get that for longevity of the unit. 2-inch double wall foam construction, both the base and the walls, again, always standard with our equipment. Enthalpy recovery device options, we talked about the core, the wheel, the different types of materials we're offering here. So a lot of different options depending on maybe owner preference, or just maintenance standpoint, cross leakage, application, right? A lot of different reasons why you might use one over the other. Stainless steel drain pan, standard with this equipment. I would say that's a given, right? Direct drive plenum fans with VFDs, because we can apply this to many different applications. Our supply fan can be modulating, that is standard. Stainless steel heat exchanger, that actually comes with a 25-year warranty on the heat exchanger tubes. Lead inverter compressor, we have standardized on to improve efficiencies. And a lead EC low sound condenser fans. Low sound condenser fans are a standard across the board for all of our condenser fans. And then we have standardized on a lead EC as well. So you'll notice that swept blade design, kind of that sawtooth in the fan blade design, that is a standard feature to reduce the sound coming off the condenser fans. Again, standard feature with our equipment. And then finally, just again, updating you, the biggest update and change with our equipment is adding an Enthalpy core. We've offered Enthalpy cores for many years on our preconditioner technologies that we offer with our ECV mini core technologies. So this is just an extension of what Greenheck's offering with a package DX system, adding it to our RVC model packaging with heating and cooling. So we do offer cores all the way up to 70 tons. You can see the airflow ranges listed here. We do offer both polymer and fiber here. I would say polymer gives you the ability to wash that core in place. So that's definitely an advantage. As long, in addition to that, it provides a little bit higher effectiveness as well. Now, just to give you a brief glimpse into the future, so what are we working on as Greenheck? Obviously, a lot of the compliance initiatives we went over today. We're updating to the ISMRE2. Currently, we list ISMRE in our submittal package, so we'll update to the ISMRE2. UL 60335 changes for that safety standard are required by the end of the year. And then we are also working on a conversion from R410A to 454B. And that conversion has to happen by 2025. So a little bit further out here, but definitely something we're working on now because it is a big shift and a big change. A few other things we're working on is startup simplicity. We're making a lot of controls improvements. You saw an example of a sequence we have for out-to-air reset to handle different changes in the code. Startup tools and QR codes go along with that for startup simplicity. And then a few product enhancements. Our smallest housing, we're working on some expansions to our RB10 that goes from 3 to 7 tons, adding energy recovery, chilled water, hot water coils to that unit, and expanding air source heat pump technologies, and then looking at a larger unit. So just to give you some glimpse into what Greenheck is working on too. So obviously lots more opportunity to provide you with more features and capacity with this equipment. So that is all I had for everyone today. I guess I'll open it up to Tracy if there are any questions.
Yeah, we do have one question on here. What are the disadvantages of microchannel coils? Are leaks more difficult to identify and repair?
So that's a great question. That has always been, I would say, the stereotype of microchannel coils. So when microchannel coils first came out, I would say that was the biggest issue people saw in the market is now you have these much smaller tubes and many of them versus the fin-in tube. Now you have bigger diameter, but less of them, right? So how do you get in and repair those? So obviously that process has evolved over the years. We now have actually seen a significant shift in the amount of leaks by switching to microchannel coils. They have greatly decreased. So there's more durability in having smaller tubes close together than having the multiple. But there are processes to repair them. So actually we have a process to repair leaks if it were to occur on a microchannel. Like I said, we've actually seen a great reduction in the amount of leaks going from fin and tube to microchannel. So that's obviously great to see, right? But we do have repair processes, and we're actually this week in the middle of recording some of those repair processes to put on a YouTube channel. So they're definitely repairable. I would say that's probably been the biggest disadvantage historically, but we aren't seeing that to date.
Okay. Did you mention the ISMRE test standard is AHR 940 or 920?
920.
Does the ISMRE ratings preclude DOAS units that furnish room neutral outside air?
So, right, that ISMRE2 or ISMRE 270, that is going to be where your biggest difference is. So ISMRE2 rating will be, the rating manufacturers will provide won't be tested to go to 70. You would have to look at the 270 ISMRE rating, which isn't what code's going to show you, but there is a rating. As a manufacturer, we would test for both.
Okay,